So this will begin part 3 of our video series with 8th grade geometry standards. So I want to begin with an area model proof of the Pythagorean theorem, because that's what we're going to look at is Pythagorean theorem, and then we'll look at some of the geometric formulas with cylinders, cones, and spheres. But to start off, we're going to create a triangle. And what I have here is a 1, 2, 3, 4 by 1, 2, 3, 4, 5. So the lengths of the what we'll call the legs of the triangle are given. So with the Pythagorean theorem, you're going to take the sides of the right triangle and you're going to create squares. So if this one at the bottom leg is a 1, 2, 3, 4, 5, then what we're going to do is create a square that is a 5 by 5. And so what we have here is a square that has an area of 25 square units. Now we'll take the vertical leg of the triangle, and we know it's 1, 2, 3, 4. So we're going to create a 4 by 4 triangle, or 4 by 4 square. And compute its area. So this is a 4 by 4, so that area would be 16 square units. So together we have 16 and 25, so that should be 30 and 11, 41 square units. Now I need to create the area off of the hypotenuse, and so that word hypotenuse is the long side opposite of the 90-degree angle in a right triangle. So to create that, though, we have a tilted square. So, or that rhombus look about it. But what we've got is we know that it's got to look something like this. But we can't just estimate that. We need to figure out what the exact endpoints would be. So to do that, you've got to create perpendicular lines. And from what we talked about with your transformations with rotations, we used, remember, 90-degree angles. So with this line right here, I want to create a perpendicular line here and a perpendicular line here. So the slope of this line is 1, 2, 3, up 4, 1, 2, 3, 4, 5. So up 4 to the left 5 would be the slope. So I know that I've got to go in the opposite direction. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, and that's going to be one endpoint. 1, 2, 3, 4, 5, 1, 2, 3, 4, and there's the other endpoint. So I can create those and then create this section here. So based on those slopes, I have created another square. Now I need to subdivide this square. So if I subdivide it, which was something that we talked about in the 6th grade standards, to find the area of that, we can subdivide it into shapes that we know. Now this triangle right here is a 1, 2, 3, 4 by 1, 2, 3, 4, 5. So 4 times 5 is 20. half of 20 would be 10. So we know that each of the triangles are going to be 10. And then what we have here in the middle is a 1 by 1. So that's 10, that's 10, 10, and 10. So there's your 10, 20, 30, 40, 1, which would match the sum of the 16 and 25. So that's just one example of a proof of the Pythagorean theorem. I have some additional videos in the module that will that can give you a different viewpoint, different visualization of this as well. So let's take what we know about the Pythagorean theorem, which is a squared plus b squared equals c squared. And so I didn't write that earlier, but what you've got is this a squared, because we're calling one of the legs a, the other leg would be b, and we're squaring it, and the final, or the third side would be c, and we're squaring it, because that's what we created, was the third square area. So a squared plus b squared equals c squared. So when we use that formula, if I have in baseball, if I have the home plate or pitcher's mound and I've got home plate, what I've got is this distance here and this distance here. Well, the catcher's throwing from second to first, or from home plate to second. And so what I've created is this right triangle. So the distances around the bases are 90 feet when we're dealing with baseball. So if I want to figure out what's that distance from second, or from home to second, then I'm solving for c squared. A squared would be 90 squared, b squared would be 90 squared. So that's 8100 plus 8100 is equal to c squared. So I add those together and I'm going to get 16,200 is equal to c squared. But I need to know what the square root of those would be, because I'm trying to figure out the opposite of squaring, which is the second root. So when you do that, you're going to take the square root of 16,200, and that would be 127 and approximately, we'll just round that, 127 and 7/10. And that is not 7/10, but 3/10, 127 and 3/10 if I'm rounding to the tenths place, and that's feet, because that's a distance. So that distance from home plate to second base when you're dealing with baseball, or if you're dealing with softball, and because the second one is if we were dealing with softball, we know that the distance from home to first is 60 feet, and first to second is 60 feet. So we're working the same problem. We're just trying to figure out how far a catcher would throw from home plate to second. So that would be 60 squared plus 60 squared is equal to c squared. I'll put c instead of x. So we'll have 3,600 plus 3,600 is equal to c squared. So that would give me 7,200 equals c squared. So I want to take the square root of both of those, and that's going to give me approximately 84 and 9/10 feet. So what we found was the hypotenuse on both of these types of problems, because the first base and second base paths create a 90-degree angle, and the hypotenuse would be from catcher to second base. All right, let's look at another problem. On figure 1, I know that I've got segment AB, and I want to know what segment AB would equal. So I can't just measure that with a centimeter ruler or in inches to figure out that length. I mean, I can, but what I would want to know is a value maybe to the nearest tenths or the nearest hundredths. But to find that measurement, I can create a right triangle, especially on the coordinate plane. So I know this distance is 3. I know this distance is 4. And so we're looking for C. So we would say 3 squared plus 4 squared equals C squared. So 3 squared is 9. 3 times 3 plus 4 times 4 is 16. So 16 plus 9 is 25, and that's what C squared equals. So when we take the square root, we're going to get C is equal to 5. Now we actually get plus and minus 5 when we take the square root, but we're talking about length. So length's not going to be negative. So we're going to be looking at 5. Now C is 5. What this is called, since all the lengths are whole numbers, this is what we call a Pythagorean triple. That's something you can Google if you want to look at it in different Pythagorean triples. 3, 4, 5 is one of your special ones. Now, if we look at figure 2, notice that we had to add the sum of the squares to figure out the hypotenuse. Well, here we know 4 squared. We don't know the other leg, but we know the hypotenuse is 11. So this is one of those where we would have to subtract. 11 squared is 121. So I'm going to subtract 16. And that's going to be b squared is equal to 121 minus 16 is 105. And that is not one of our perfect squares. So when you take the square root of 105, you're going to get, we can leave it as the square root of 105, or we can approximate it, because the square root of 100 is 10, and the square root of a 121 is 11. So we know it's between 100 and 121. So we could say it's about 10 2/10 units. So with figure 2, we had to subtract to find the other leg. With figure 1, we had to add to find the hypotenuse. And this is one where it's an example where if you still had, if this was still your 3, 4, 5 right triangle, that we could go through the same proof as we did over here with area. We could do the same proof with area dealing with circles. And so what you would need to do is look at your recall from 7th grade standards, which is your pi r squared. So if we did use the formula of the pi r squared, then we would have to think of, well, if this diameter is 3, then we would have to say approximately, we can use pi times 1.5 squared. And then we would look at that area. And then here, with the length of 4 as the diameter, we would do the same thing, and we would use pi approximately, and we would use 2, and we'd have to square 2 to find the area of this semicircle. And then if this length is 5, then that radius would be 2.5, so we'd have to square it, multiply it by approximately 3 14/100, and that would give us the area of this semicircle. So we would say that this area plus this area would equal this area. Looking at number 5 here, we're also dealing with the converse of the Pythagorean theorem. The converse is just saying, as I have in there, if the square of one side of a triangle is equal to the sum of the squares of the other two, then the triangle is a right triangle. So that's all we're saying, is we're just trying to prove it. So if we're looking, we've got our formulas here. So I'll just split the page here. If we have 154 squared as one of the legs and 72 squared as the other leg, it better equal 170 squared for it to be a 90-degree, a right angle. Well, 154 squared is going to be 23,716 plus 72 squared, which is 5,184, and 170 squared is 28,900. Now, if you add these two together, you're going to get 28,900, and that checks. Since it equals, we know that this is a right triangle. Now let's check the other one. So we're going to say that 3.5 is our one of our legs. So we're going to square 3.5. We're going to square 4 2/10, and we're going to square 4.5. Well, if we square 4.5, we're going to get 20 2500ths. If we square 4 2/10, we're going to get 17 6400ths, and 3.5 squared would be 12 2500ths. Well, if you add these together, you're going to see that it's 29 8900ths. It does not equal. So I can put the slash through it. It does not equal, so therefore we know that this is not a right triangle. So that's our converse of using the Pythagorean theorem. So with the practice here, I want you to determine the length of segment AB. And we will use and create a right triangle to do so. And we know this length is 3. We know this length is 6. So we're just trying to figure out the length of the hypotenuse. So we know that's going to be 3 squared plus 6 squared equals c squared. And that's going to be 9 plus 36 is equal to c squared. 36 plus 9 is going to be 45, and 45 is not a perfect square. 6 times 6 is 36. 7 times 7 is 49. 45 is going to fall somewhere in between there. So when you take the square root, we would say that the length of the segment is the square root of 45. Now, if you want to do an approximation, we know that the square root of 45 falls between the square root of 49, which is 7, and the square root of 36, which is 6. Well, it's actually 9 units away from 6, and it's only 4 units away from 7. So it's definitely closer to 7. So we would say approximately 6 7/10 would be the same approximately as the square root of 45. Given the right triangle, you're using the converse of the Pythagorean theorem. You can take a moment, pause the recording, pause the video, and determine if this is going to be a right triangle. So as you have resumed the video, you would say, well, 27 squared plus 36 squared is equal to 45 squared. And so 45 squared is going to be 2,025. 27 squared is going to be 729, and 36 squared is going to be 1,296. When you add these together, you're going to get the 2,025, so they do equal. So this just means that it is a right triangle. All right, and our last part of this is looking at the different formulas. Now, I've given you some videos in your module that really take you through why the cylinder formula is what it is, why the cone is what it is in comparison to the cylinder, and then how we can look at how the cones are in relationship to creating the cylinder, the sphere formula. So with a cylinder, which you would see again in your video, is a volume, and it has pi r squared in its formula. Because remember, a cylinder has a circular base. The only difference is it has a height. So the cylinder formula is going to be volume equals pi r squared h. But then when you think of your cone still has a circular shape. So the cone has to have, as a volume, it also has to have pi r squared h, because it's going to have a height to it, and it's going to have a circular base, which is pi r squared. The only difference is that the cone is a third of the cylinder, based on that the diameters of the cylinder and the cone are the same. And then looking at the sphere, we have volume is equal to 4/3 pi r cubed would be the formula. Notice that they all have pi involved in the formula because of the circular piece that's built in. So if I want to determine the volume and I give you a cone, we're going to use volume equals 1/3 times pi times the radius squared times the height. So we know that the diameter is 3.5. So half of 3.5 would be 1 75/100, and you need to square that. The height is 4, and we can use 3 14/100 as an approximation, and then we can also just say that we're going to divide the entire answer by 3, because that's the same as multiplying by 1/3. So when you square 1 75/100, you're going to get a value. You've got your height and you've got pi, and you're going to divide it all by 3. So when you do so, you're going to get about 12 8/10 cubic inches, cubic due to volume. Well, you can also just do an estimate here. You could see, well, that's about 3, and that's about 3. So that's 3 times 3 is 9. 9 times 4 is 36, and 1/3 of 36 is going to be 12. So we know that our answer is, our estimate is would be pretty close. Now let's look at a cylinder. So the volume of the cylinder is just going to be your pi r squared, which is the area of your base, right? But then you've got a height that you're dealing with. So we've got to bring in the height. So the volume would be, we can use 3 14/100 as pi. The radius is going to be 10, and we're going to square that, and the height is going to be 30. So we're going to have 3 14/100 multiplied by 100 multiplied by 30. And so 100 times 30 is going to be 3,000. And then 3,000 times 3 14/100, so we're going to get approximately 9,420 cubic centimeters. And that makes sense because pi is approximately 3, and the other results of radius squared times height is a 3. So 3,000 times 3 would be about 9,000, and that checks for our answer. For your sphere, we know we're going to have 4/3 times pi times the radius cubed. The radius is 9. So we're going to take 9 and we're going to have to cube that. And then here's another way to write this, is we're just going to multiply by 4 but divide the entire answer by 3. So if we multiply 4, well, if we do 9 to the third power, we're going to get 729 multiplied by approximately 3 1400ths multiplied by 4, all divided by 3. So remember, when you're doing a calculation on the calculator, go ahead and multiply the numerator first. So 729 times 3 1400ths times 4. Hit enter, divide all that by 3, and you're going to see you're about 3,052 and 800ths cubic centimeters. So the next one, we've got the volume of a spherical ball would be, so if we know the volume is 5,000 cubic centimeters, what is the radius? Well, if we're dealing with the sphere, then we know 5,000 is the volume. We're dealing with 4/3 times pi times the radius cubed. So with this one, I'm going to go ahead and multiply both sides by 3 to give me 4 times, and I'll change that to 3 1400ths. So this will be 15,000. And then what I'm going to do is take these two together. So I'm going to take 3 1400ths multiplied by 4. I'm just doing that on my phone calculator. It's 12 and 5600ths multiplied by r to the third. And then what I'm going to do is divide both sides by 12 and 5600ths. So I'm going to take 15,000 divided by 12 and 5600ths, and I'm going to get about 1,194, and this is what shows up on my calculator. Well, I need to take the cube root of that. So if you have an iPhone calculator, you can actually rotate your calculator to see more functions. You can also do an online calculator if you need to. But with my iPhone calculator, I can rotate it, and I'm looking at the third row, third column. And so I'm just going to hit the cube root button of that. So that's going to be about 10 6/10. And since this is centimeters, the radius would be about 10 6/10. So that's a problem where you knew the volume and you needed to solve for the radius. Here we know that the volume of the sphere is a diameter of 12. Find the volume if the sphere has a diameter of 12. Okay, so I've got 4/3 times pi times the radius cubed. Well, if the diameter is 12, then the radius is 6 because we got to take half of that. So if I take 6 and cube it, I'm going to get 216. And I'm going to multiply that by pi, and then I'm going to multiply that by 4, and then I'm going to divide all my answer by 3. That would also be the same as just multiplying by 4/3. So if I take 216, multiply it by 3 1400ths, hit equal, and then multiply by 4, I'm going to get 2,712 and 9600ths. But then I want to divide all that by 3. So I'm just going to hit divide by 3 on my calculator, and my volume is going to be about 904 and 3200ths, dealing with centimeters, cubic centimeters, approximately, because we're using pi as 3 1400ths. So that's going to conclude part 3 of this video series. And our last video series dealing with standards of geometry in the grade span that we were looking at. So this will conclude 8th grade geometry standards.